Good morning, Vandana. Today my topic is short columns, which is related to the analysis of aircraft structures. First of all, in short column, what is column? A structural member subjected to an axial compressive force is called as column. Normally, columns carried heavy compressive loads. Columns are used in concrete and steel buildings. Yes. And real world examples. Those are two real world examples. There are a lot of which are under construction. We came to know that they are under construction of columns, in which we can able to identify for any artificial products like chair and any other things. We can able to know that the columns plays a major role. And there are three types of columns in which they are short column, long column, and intermediate column. First of all, the basic introduction of a long column. Classification of long column. When the length of the column is more compared to the C by S dimensions, its column is known as long column. The long column LE by R minimum is greater than 50, whereas LE is known as effective length of column, and R minimum is called as minimum radius of gyration. And real world example, here in the picture we can see now. A real world example, here is a picture, we can see the long columns on the front of the building. The building is known as White House, which is in the Washington DC. And short column, when the length of the column is less as compared to its C by S dimension, is known as short column. And short column LE by R minimum is less than 50, or LE by D is less than 50. Whereas crushing load, the load at which short column fails by the crushing is called as crushing load. An intermediate column. Intermediate column is intermediate when 4D less than L less than 30D and 30 less than LE by R minimum less than 100, or critical slenderness ratio. Before we move onwards, these are basic keys which place in the columns. Gripping load, which is known as PCL, radius of gyration R, moment of inertia A, area equals to A, and effective length LE, slenderness ratio lambda, strong slenderness ratio which is lambda, and strong axis and weak axis. And there are supports, roller type support, pin type supports, fixed supports. And effective length, the distance between the points of two zero moments depend upon the type of support conditions. And column end condition and effective length, both end are hinged, both ends fixed, one end fixed and other hinged, and one end fixed and other is free. Where LE for a different supports of conditions, where first one is one end fixed and one end is free, where we can able to observe that LE equals to 2L. The second is both ends are pinned, in which they are both are fixed, where LE equals to L. And one end is fixed, one pinned, where LE equals to 0.7 into L, and both ends are fixed, where LE equals to 0.5 L. And slenderness ratio is denoted by the lambda. Slenderness ratio is the ratio of the length of the column and the least radius of gyration of its cross section, often denoted by the lambda. It is usually extensively for finding out of a design and loads as well as classifying the various columns, short, intermediate and long, where lambda equals to LE by R minimum is known as slenderness ratio, where radius of gyration R equals to under root I by A. I is the moment of inertia, where A R square, where K is the radius of gyration, I is the moment of inertia which is taken in millimeters, and A equals to area of section. The slenderness ratio equals to effective length of a column by minimum radius of gyration, where lambda equals to LE by R minimum. Gripping load or a buckling load. The load at which the young column starts buckling is called buckling load or crippling load. Buckling of a column depends upon the following factors: among amount of load, length of column, and condition of column, C/S dimension of column, materials of a column. Where Euler's formulas, Euler's crippling load P equals to pi square E by L E square, where E is the modulus of elasticity, I is the moment of inertia or moment of area, and L is the effective length, and also known as critical buckling load.